two things here. We want to find outliers, and then we want to find unusual values. Right? Computationally, it's not going to be bad because all the functions that we need are built into Excel. Right? And again, you can go back and forth with Excel or Google Sheets any way you want. It's just I like the sharing capabilities of Google Sheets a little bit better. That's why I always go for that. All right. So, and also like anything I do on my Google Sheets is my property. So if I use Excel through the district, I have to. They own my work, and I don't like that. All right. So for outliers, we need. If you think back to what we did in the notes, really three pieces of information, but two unique pieces of information. We need the first quartile, the third quartile, and then the difference between the two, giving us the interquartile range. So I'm going to put a cell here that says Q1 for first quartile, one that says Q3, and one that says IQR. Now, the skill that I'm about to show you isn't new. Right? We did this when we created box plots. All right? So my quartile function equals quartile EXC is the one you want. All right? The one that's exclusive of the endpoints. All right, so quartile EXC, and then just highlight the data. Now it's a big chunky data set here, which is one of the reasons why we go to Excel. You know, some of the other examples I gave you, they could have easily been done by hand, but this would be a lot to type in. Right? Even though it's only 30 some odd values, maybe only exactly 30, some of them are 7 digits. You know, that's a lot. All right? So you type this in quartile EXC. When you start typing in quartile, the EXC part of it comes up. You click on it or tap on it. B3 to B32. All right? Because with trackpads, we talked about this 2 days ago. Instead of using a mouse, the trackpad, it could be a problem because it's hard to kind of get where you want to go. I use a Bluetooth mouse most of the time, so you know if you want to do that, you can, but it's just another thing to buy. So I tend to stay away from telling people that they should do that. All right, but anyway, I'm going to hit enter. It says NA because I screwed something up. Oh, I paused for dramatic effect and forgot to tell Excel, Google Sheets, that I want the first quartile. All right, so data and what quartile you want. You just type in the one. So you type in quartile equals quartile, select EXC, select the data, and then comma 1. Yeah, I know, it's tough to see. When they told me years ago that I'd be getting a big screen TV, I thought it was going to cover like most of the wall. Like it was going to be great. And people have been straining to see what I've been typing ever since. All right, I'll do it again for Q3 because it's really the same thing. Equals quartile. You start typing in quartile, you see the one that says EXC. Get your data, whether it's by highlighting or typing in B3 colon B32, but then comma 3. Comma 3, the 3 represents the third quartile. All right. IQR is the easy part of this. Like super easy. All you're doing is taking the difference between Q3 and Q1. So you're going to put equals whatever you have in Q3 minus whatever you have in Q1. So mine is E4 minus E3, but yours could be, different column, different row, because depending on where you put your Q1, Q3, it would refer to that. So I have my IQR, which is a monstrously large value. It's really not that bad. But we are talking about area and square miles for different countries. These countries were selected at random. So, I mean, there are some that I was like, oh, I didn't even know that was a country. But you look at a place that has 12 square miles, I would imagine that's probably an island country. But, like Antarctica, 14 million. I mean, how much of that is populated, Like 1 square mile? No, it's probably an exaggeration. So anyway, for the bounds, I need to come up with the low bounds and the high bounds for the outliers. All right, so I'll just label this outliers. I'm going to say the low bound, and I'm going to say the upper bound. All right, this is a lot of the same stuff that we did with the empirical rule. It's just we're referring to different points. All right, so you get a little muscle memory when you do this stuff. All right, so the low bound is going to be, if you think about the formula, I know we're not actually looking at it right now, but sometimes they call it LQ, so I'm stumbling a little bit, but Q1 minus 1.5 times the IQR. So I'm going to say equals, I have my Q1 here, minus 1.5 times the IQR. All right, and that's going to give me my low bound. So for me, that's E3 minus 1.5 times E5.
How do you do the times?
Shift 8. Shift 8 for multiplication brings up the asterisk.
Times what?
E5 in my case.
Or the IQR?
The IQR, exactly. All right, E3 minus 1.5 the IQR. So Q1 is E3 minus 1.5, and 1.5 is always there. The IQR I have stored into E5, so minus 1.5 times E5. All right. And again, you could type on it or you can click it. If you're having trouble with the clicking, I know people have, then that could be an issue. So I'm going to hit enter, and I have my low bound for outliers. Now, just through observation, I can look at this and say, well, I'm not going to have any outliers lower than this number because this is a negative number.
For Q1, what'd you do after that? How'd you the comma work for the
So to get this number itself?
Yeah.
Okay, let me delete. So you're hitting equals quartile, selecting EXC. All right. So you grab that one, type in the data reference points, and then right after that, just hit comma on your keyboard, and then a 1. And that 1 corresponds to the fact that it is the first quartile. Right. And same idea for Q3. Now the upper bound, I'm going to take my Q3, add to that 1.5 times the IQR. All right. And then hit enter. And now you have the upper bound for outliers. Now, there's two schools of thought on this. One way to determine if there are any outliers would be to go through your data manually and say, is this number between these two numbers? Yes, it's not an outlier. Is this number in between? Yes, it's not an outlier. But we want Excel to do the work for us. Question?
Can you do the upper bound again?
Yep. So equals Q3. So we click on our Q3 value, plus 1.5, typing it right in, times, that's the shift 8, and then select your IQR. And then once you hit enter, it's going to give you that massively large number.
And then for the lower bound, it's plus 1.5? Or, minus 1.5?
Minus 1.5, yeah.
How do you find the IQ?
Q3 minus Q1. So IQR, I just did this number, so equals this number minus this number. Well, if I actually type anything, minus this number. I overwrote it accidentally. I'll do it again. Equals this number minus this number. All right, Q3 minus Q1.
Could you do the lower bound again?
Oh, sure. Yeah. Third time's the charm. All right, so for the lower bound you said. All right, second time's the charm. All right, so lower bound is going to be Q1 minus 1.5 times the IQR. All right, so for me, that's E3 minus 1.5 times E5, but yeah, it all depends. So I have my bounds. And again, we want Excel to determine the number of values that are beyond this interval. All right. So we wanted to identify how many there are. But in this case, it's saying find any outliers. So you could actually just identify them. If you want to, and I'll show you real quick, you take your entire data set. I'll just pop it into a new column. I'm just copy pasting and sort it out. Right? If they were asking for how many, I would get into like the count if and things like that, like we did for empirical rule. But here they actually just want the particular values. So once you copy and paste it into a new list, go to data, you'll see sort range as an option. Sort range. So data, sort range. Highlight the information, data, followed by sort range. And you'll see A to Z or Z to A. So that's lowest to highest, highest to lowest. Now I have my data in order. So I'm looking at, and there are more advanced ways of doing this, but let's do it one step at a time here. I'm just going to go down my list. This is roughly 1.8 million. So I would be looking for any number that's bigger than roughly 1.8 million. That's 1,817,000. So I'd be looking at any of these values as outliers. I'm going to go with a fill option here. Those would be my outliers.
How do you fill it? Oh, I see.
Yeah. So I'll just make a note, outliers highlighted in yellow. Yeah, pick your favorite color. It doesn't really matter. All right. But since there are no negative numbers in my data set, and we're talking about context, area, landmass area, I'm not thinking that there would be any outliers on the low end or any values that would be negative. All right. So based off of this data set, like Bolivia, for example, 14,200,000, that would be an outlier. All right. Oh, actually, that wouldn't be Bolivia. Sorry, because I sorted the data. That would actually be Antarctica. Right? I only sorted the numerical values. I didn't sort the names that went with it. You could do that too if you want, but it's not required. I could show you how to do that. It's probably not the worst idea in the world. If you want to sort 2 columns of data based off of a numerical value, so I have numbers that are in my B column, and I want to sort those, and I want the countries to get sorted along with them. What you would do is highlight, but start with the value, the first value in the column that you want to have sorted. Highlight and go left. It'll sort everything here based off of the numerical values. So data, sort range, A to Z. So you could actually do it by numbers and have the actual labels come along with it. So you can see Antarctica is where it should be. All right. I personally like to preserve the order of the values, but it really doesn't make a difference for this kind of problem one way or the other. All right. So I'm going to put it back the way it was, but you could feel free to do that. Now, if they said what country corresponds to those outliers, then I'd have to look at it and say, all right, well, going back to my original data set, that would be Kazakhstan. 85 and change. Where are you? 85. Oh, actually 8.15. There we are. Brazil. And then we'd have China. And Antarctica, wherever that ended up. So if you needed the names to go along with it, you'd have to do that also. All right. Now, the approach for unusual values is going to be pretty much the same, except we're using mean and standard deviation instead of the Q1, Q3, and IQR. So just going over, same set of data, just we're looking for something different. So I duplicated the data so you hopefully wouldn't get confused. So mean, standard deviation. Now these are all samples. Everything we work with in this unit are samples, so there's no You don't have to worry about anything like population. So for mean, we use the average function. All right. I can't tell you how many times I've accidentally started equals mean because that's how I say it every day. But we use the average function. Highlight the information, nothing fancy. Hit enter. And it'll compute the mean. It'll also do the suggested autofill, which I don't want. The standard deviation equals, start typing in standard deviation, but grab the one for the sample. Standard deviation sample. All right.
Could you do the lower and upper bound again?
For the first set?
Well, just in general. I'm just like following along.
Okay, one sec. Let me go back to that. So for the lower bound, I'm just going to clear out what I have here. It's equals Q1 minus 1.5 times the IQR. IQR is IQR. And then for the upper, it's Q3 plus 1.5 times the IQR. All right. So Q1 minus 1.5 IQR, Q3 plus 1.5 IQR. All right. Now, just going back to standard deviation again, it's equals ST. You start typing that in, ST for standard deviation, but then click on the one that says .S, standard deviation for the sample. And again, mean and standard deviation are the two easier things that you can do because it's just highlight the data and hit enter. You don't have to put any other values in along with it. All right. All right, so I have my mean and my standard deviation. I still need a lower bound and an upper bound. All right, the low bound, just going back to the notes, X bar, which is the mean, minus 2 times whatever the standard deviation is. All right, so in this case, my X bar is right here, minus 2 times whatever the standard deviation is. All right. So as long as your row and column references, the M3 and the M4, point to where that information is, you'll get the right number. All right. So I'm going to hit enter. And now I have my low bound. My upper bound equals mean plus 2 times the standard deviation. So in this case, M3 plus 2 times M4. It's the same set of values, just with a plus instead of a minus. Enter. Now we have our upper bound, which appears to be a little bit more than 8 million. So I'll do what I did before with the outliers, copy paste, just so I can preserve the original ordering. And then sort it ascending. So sort data sort range A to Z. And just look for any value that's bigger than 8,069,000. So that would be these 3 values. All right. I like to do a little highlight, but those would be my unusual values. And you can see, if you compare it to the outliers, there's one less value that makes up the unusual values than the outliers. All right. So it's not always going to be the same. One is just a more extreme version of the other. All right. Yep. And that's really all there is to it. Actually, looking at it, I think, yeah, I'm pretty sure there's the same set of data. So there you go. All right. I put a due date for this assignment to be Monday evening, right? Just because I know it took you right up to the bell with the instruction. Right, so you'll have time in class on Monday to work on it, but I'm also going to introduce the unit project on Monday. All right, so you could kind of work on both simultaneously. The unit project should take about a week, all right? Maybe 3 days, but I'll give you the week.